Assalamualaikum and good day. Today we're going to talk about engineering design standard. The purpose for this chapter is to introduce you with specification of design. Number one is to make sure that you are aware of various standards which may be considered during any design project, and also to assist you in finding the standards needed for a specific design project. So my first question is, what are standards? Standards is an important part of the society, serving as a rule to measure or judge capacity, quantity, content, extent, value, and also quality. Some standards take the form of an actual item, such as the atomic clock, which serve as the reference for measuring time throughout the world. Others set criteria for the use and also practice in industry, and also for the products that you use in everyday life. In this introduction, however, deals primarily with standards that set a level of adequacy for maritime engineering design. In these standards, above all, must be addressed before any engineering design project can be started. So we have two definitions here. Number one is on the standard, what are standards? And number two is code. The definition of code is law or regulation that specify minimum standards to protect public safety and health, such as code for construction or buildings. Voluntary standards are incorporated into building codes. Building codes are very important because these serve as legal documents that protect both you as the developer, you as the designer, and also the people that resides inside the building. So if we can take building and we put this building, change it to a ship, so that's how we work. So we have standards and also codes. In both standards and law, we have specification and also technical regulation. When we talk about specification, we try to imagine if we have a phone and what other phones is capable to do. So specification is a set of conditions and requirements of precise and limited application that provide a detailed description of a procedure, process, material, product, or service for use primarily in procurement and also manufacturing. Standards may be referenced or included inside of the specification. If you look at your phone, you please take note on the word limited application that provide a detailed description of a procedure. So which means that if you have a phone, they are limited to certain functions that they are using. So which means that if the phone is not capable for military application, so the phone is not capable for excessive drops, the phone is not capable for excessive noise, and so on. Technical regulation is a mandatory government requirement that defines the characteristics or the performance requirement of a product, service, or process. We can see also regulation. So talking about technical regulation, we have different technical regulation. European has their own technical regulation, Australia has their own technical regulation, Malaysia have their own technical regulation. Using phone again, if we look at the phone, some of the European regulations says that a device must be able to be fixed. So which means that if the device is not fixable, if it's broken, you cannot fix it, so it's not passed, it will not going to pass technical regulation of the European. Similarly, for ship design, we have different body that regulates on the ship design, so they have different requirements for different countries. To give you some background why standard exists, there are several stories which we're going to share in this particular session. The first one is the US federal government is the largest single creator and user of standards. It has more than 45,000 by current estimates, and there are about 210 organizations are designated standard development organization, we call it SDO, and also most standards, about 90%, come from these 20 of this SDO, and some standards available are ASTM, American Society of Technology and Manufacturing, American Society of Mechanical Engineers, Institute of Electronic and Electrical Engineers. So these are some of the standards and some of the most important SDO or Standard Development Organizations. ANSI and US National Committee are the US clearinghouse for standards and the founding member of ISO. ISO is International Standards Organization. So internationally, we see standard organization in each of the major industrial nation and several umbrella groups. So there are some umbrella groups that cater for the standards: International Organization for Standardization, ISO, International Electrotechnical Commission, IEC, and also International Telecommunication Union, ITU. How we use standards? Standards is like the way you communicate whether your product is up to the standard or not. So if we say that your product is following the ASTM standard, so we communicate this is the quality of the product following certain standard of use. Standards are communication tools that allow all users to speak the same language when reacting to products or processes. Also, standard is a legal document, which means that to evaluate the acceptability and saleability of products and or services. Standards are very good because they can be taught and applied globally. So which means that if you are following certain standards, your ship, when it docks in Malaysia, you can dock in US while following the same tool and also the same catalog and also the same method of repairing. So it's very easy because if everybody is using standard, so you don't have to worry about not having spare parts in the other part of the world. So ultimately, standards are designed to protect the public from questionable design, product, and also practices. So we put everybody on the same field so that when we try to fix our ship somewhere in other parts of the world, we are going to have consistent spare parts and also service that we can expect. So let's look at some of the case study with regards to standards. In this case, the National Institute of Standards and Technology, NIST, one of the agencies of the US Department of Commerce, has conducted 3-year building and fire safety investigation to study the factors contributing to the collapse of the World Trade Center in 2001. But September 11, 2001 was not the first time tragedy helped to identify the need for standards. More than a century ago, a great fire ravaged Baltimore, Maryland for more than 30 hours in early 1904. So what is the story? It's like this. The fire was reported earlier at 10:48 a.m. on the Sunday morning, February 7, and quickly spread. By midday, units from surrounding communities were arriving, so you have lots of fire brigades come with their own fire truck, try to use a firewall, and then it doesn't work. And then what they did was they tried to use explosion. They dynamite the surrounding building to stop the fire spreading, however unsuccessful because the fire was too big. And the fire continues to the 8th February. So which means that 7th February start, 8th February there's still fire in the town. More than 1,231 firefighters were required to bring the blaze under control. So you have a very big fire and then you have more than 1,000 firefighters there. And it doesn't help. Why? Because in 1904, there is no national standards in firefighting equipment. So you have the neighboring town, they bring their own fire brigades. When they have their own tools, they want to put it in the fire hydrant. It doesn't work because there is no standards. So different states using different standard for fire pipes or fire hydrants. As a result, the fire stays for over 30 hours. And what happened is destroying 1,500 buildings spanning 70 city blocks. So it's a very huge fire. And then the National Fire Protection Association, which has been established earlier in 1896 after a number of disastrous large-scale fires, then set to develop uniform sprinkler system, standard hose coupling, and also fire hydrants. So although the Standard Fire Protection Association is there, it's not established the standards earlier before the Baltimore fire. So it happens, a tragedy happens, and then they fix it later. So talking about standards, we need to refer to documents. When you design for ships, you need to follow ship design standards. When you are designing mechanical tools, you need to follow American Society of Mechanical Engineers. When you want to design for electric or electronics tools, you need to follow IEEE. So one of the resource is IHS. So the source for critical information and insight. So you have different standards you can download from the IHS. What are the impacts of standards to business and also industry? If you look here, 80% of global merchandise trade is affected by standards and by regulation that embody standards, which means that everybody when we want to do transaction, we must follow standardization. It's very important because we need to confirm the assessment that play key roles to the transfer of technology, and also from the research and development stage to production, and ultimately to the product success. Standards are very important because we simplify product development. We reduce unnecessarily duplication, lower cost, increase productivity, ensure safety, and also interoperability. Enhance the acceptance of new products, maintain uniformity in product quality, and much more. Which means that if we have the factory in Japan and also we have the factory in Malaysia and we follow the same standard, the outcome will be similar. So which means that everybody in the same level of playing field. The only thing that differ us is product that we develop. So the spare parts and everything, we are following the same standard. Standard is very important because you don't want to reinvent the wheel. So it's not necessary for you to redraw your own screws. It's not practical. So use standard because the people who work in Japan use the same screw that you are using. So interoperability is justified. Industry participation in standard development process, for example, can sit company representative at the same table with their customers. So which means that communication wise, we are on the same page. So it's very easy and much economical than trying to retrofit a product which does not follow the standards. Standard in the news, probably you have heard a lot of available standards. ISO 9000. So this is basically a quality standards used by business, basically to say that we are quality. And in US, it has evolved into Q9001 as nationalized by AQS. And also you have UL rating. UL rating is basically Underwriter Laboratories rating. So it used as an international safety rating, hence we call it standard. And also we have ISO 14000, the International Environmental Management Guideline. So this is the de facto product life cycle and sustainable standard for business and industry. This simply means that any company that holds ISO 14000 is a company that comply with the life cycle analysis. It's a company that follow the sustainability principles. And also, normally if you are working, you are going to deal with ANSI or ASME, Y14.1 and Y14.5, which are international drafting standards for engineering drawing. So again, in IHS, we can look at specific example of an ISO standards. So this is the safety of machinery, interlocking device associated with guards, the principle for design, and also the amendment, the design to minimize defeat possibility. So the interlocking device associated with guard also have a very detailed standards that can be used for aerospace and defense, automotive, construction, electronics, energy, and also maritime engineering. So don't worry if you are there in company that create designs. You can always follow designs available in the internet supplied by several organizations, including IHS, Thomson Reuters. So follow this, and also that in return, your company will going to be able to use the same spare parts that you create in their other products. And this is something that you probably use when you are running CHARPY impact tests in the laboratories. If you take note in the introduction of your lab reports, they use ASTM International Committee on Mechanical Testing approved ASTM E2248 test method for impact testing of miniaturized CHARPY V0 specimen, and also the test method for instrumented impact testing for metallic materials. So this can also be referred to ASTM standards, can also be referred to for drop tests if you are dealing with packagings of spare parts for ships, and also during your operation with ships, definitely you're going to deal with vibration. So you need to refer to vibration standards in order for you to create reports and also try to troubleshoot. Another example, this is for noise control. So the one that I've mentioned just now is on the vibration and also noise on ships. So this is the Acoustical Society of America, ANSI S 12.19, 1996, R 2006, revision 2006. This is the measurement of occupational noise exposure. So you are working inside of the ship, and then you need to make sure that you are able to say to your workers, please stay inside of this ship for not more than 3 hours. So we refer to these standards to measure a person noise exposure received in workplace. So the method that has been developed to provide uniform procedures and repeatable results for the measurement of occupational noise exposure. So this is very important for people who work inside of the engine room. For the marine engineering standards, so we have different standards that we can use other than the generic mechanical engineering or also electrical engineering. So we have ships, naval ships, and also high-speed craft and submersible. We have Australian Maritime Safety Authority or AMSA, that replaced the National Marine Safety Committee of Australia and Uniform Shipping Code, Law Code, USL. If you are building bigger vessels, you have National Standard for Commercial Vessel. So if you download this note from the e-pembelajaran, definitely you can right-click on the link and download the standards. National Standard for Commercial Vessel is progressively introduced to replace the USL code, the Uniform Shipping Law Code. The publication of the standard implies that the standard have been endorsed by the Transport and Infrastructure Council of Australia. Other standards, we have Rule of Classification of Ships. We call it that Noscea Veritas. Full text available. You can right click and save. Rules for classification for high speed, light craft, and also naval surface craft. This is by the that Noscea Veritas. Others are layout register, and others below are layout register. So now we have the Noscea Veritas, you have Australian Maritime Safety Authority, and then you have the layout register, and now we have below we have American Bureau of Shipping, and also Germanische layout. So these are the standards that we can use for marine engineering standards. When I was doing my PhD is more towards the design of high-speed craft. I refer to this rule for classification for high-speed, light craft, and naval surface craft. For this particular ship standards, they have standards for operability of ships on the high-speed craft. Other than the marine-specific standards, we can also take a look at the professional societies pages. So here is American Society of Mechanical Engineers Codes and Standards. Example of use for mechanical engineering students. So you can download this. It's a 20-page introduction for standards, and they teach you how to read the standards. And this is handbook for standardization for ASTM, and this is the ISO 9001-2008 Quality Management System Requirement Standards. The American version of the update is here. Standards you need to read and also try to comply. This is also good for a selling point of the product of your company. Okay, now we would want you to think forward. Other than standards that require you to follow the noise requirement, and also that require you to follow the vibration level and also to follow the noise level, there are other standards that we call life cycle assessment. Life cycle assessment is a sustainability indicator of your product. So which means that if your product is there, is it be able to be recycled? Is your product is using recyclable materials? And is your product is not harmful for the environment? So in this particular cradle to grave thinking is very beneficial, because we cannot continuously pollute our earth. So we need to have cradle to grave thinking to ensure that the next generation of humans be able to live in cleaner world. So use life cycle assessment to indicate that your product is sustainable for the environment. And also for standards, we have ethics. So other than the standards on tooling, you have standards for environment, and also now standards on ethics. So here we have the Code of Good Practice, Standard Guide for Confidentiality, Privacy, Access and Data Security Principle, Standard Guide for Amendment for Health Information, and also the Disclosure Law for use in health information systems, and also studies to evaluate patient outcomes, the approved guideline. Other than engineering standards, we need to focus also on the ethics to make sure that we cater for a long-term capability of humans to work inside of the engineering. So this is very important. So to end this class, I would want to have you to consider that standards is very important. We try to consider standards as part of the professional engineering job. We need to also make sure that standard is part of your lifelong learning process, and standards will change because every year we look at the example of the Baltimore big fire. Standards are being re-evaluated and being improved year by year to cater for new situation. So please check often for changes, as they will affect your products and also processes as an engineer and also manager. So thank you so much for your attention in this class, and see you again.